Alright, time for the math. Easy solution to discuss related rates and what they are and look at some examples. This is really useful in real life and whatnot, and you'll get this a lot in calculus. So basically, related rates are just, it's basically what it means is determining the, so basically you determine the rate of change of one quantity versus, based on the rate of change in another quantity, which is easier to measure. So I'll just write this down. Okay, so I just wrote it down right here. It's basically determine rate of change of one quantity based on rate of change of another, usually easier to measure. What I mean by this is, well, we'll look at an example here. Let's go example 1. If you had a balloon, and say, let's say you had a balloon here, and you are basically filling it, it's circular balloon, let's just say it's circular balloon, and you're filling it at a constant rate. So you basically, let's say you're filling it at 100, let's say 100 centimeters cubed per second. So basically this is the volume changing, and let's say you want to know how fast is the radius changing, say the r, and then but you want to know what this rate of, let's say, r prime is changing. So basically finding out the change in radius, or let's say change in radius, yeah, let's say rate change of radius, it's hard to measure, whereas the volume here, it's a bit easier to measure. Like if you were filling it in with air, you can easily measure the rate of volume or amount of air you're sending to it, but the radius is hard. So now let's say you wanted to know what the radius is. So let's say you have a circular, let's say, balloon, you're filling it at, let's say you're filling it at, yeah, let's say, well, rate of change is just derivatives. So rate of change, or is just derivatives, because that's all derivative is a rate of change. And let's say, so at rate of change of the volume is, or V prime, is equal to 100 centimeters per second. And let's say, so you're filling it at this, and let's say what is the rate of change of the radius? What is r prime? Yeah, r prime at, let's say diameter is, let's say 50 centimeters. At diameter equals 50 centimeters. So basically this is the whole idea of related rates. So you look at the rate of which is easier to measure, or you're usually given if you're doing calculus or whatnot. So rate of change of volume, what is the rate of change of radius? And this, in this case, r prime is just equal to, well, rate of change of dr over dt in terms of time. So rate of change of radius per time. Basically, you have to look at get a formula of the relation between volume and radius, and you just do derivative and then using chain rule. So the chain rule is going to come in handy. So basically, we know that the volume of a sphere is just 4 over 3 pi r cubed. And then, so all you gotta do is find an equation of the two, and then take derivative, and then you'll plug in the numbers. So basically, in here, the derivative of v prime is just gonna equal to 4 over 3, again, pi, derivative of this one, the 3 goes down, so we're gonna go 3 times that, r squared, using power rule. And then using chain rule, r prime. So right here, these cancel, we're gonna get v prime is equal to 4 pi r squared times r prime, and we know that the rate of change you're filling it is constant as 100 centimeters cubed, so equals to 100 cm cubed over seconds. And this, again, remember, this is rate of change versus time. So now what is this rate of change of r? It's basically at d is equal to 50 centimeters. That just means, well, this is just the radius is 2r, or 2r, so then r is equal to 25 centimeters. Just make sure the units are right, so they're all centimeters here. We just plug it in. So we're going to get r prime is equal to 100 centimeters per second divided by 4 pi, r is just, well, 25 centimeters squared. And then the units, these centimeters cancel because they're squared, and then you're just going to get centimeters per second. And you plug this into calculator. Okay, so just grab the Google calculator here. Let's go 100 divided by 4 times pi times 25 squared. Yeah, this equals to, well, let's press enter here. Yeah, so this equals to this right here, or 0.0127. 127 centimeters per second. Yeah, and that's the units here. Or if you're in calculus and you want to simplify this one, you didn't have a calculator, you could just break it down to this one will just equal to, well, 100. Let's see, we'll just ignore the units for now. Divided by, well, 4 times 25 times 25 times pi. And this is 4 times, this is just 100. And these cancel, so you're just left with 1 over 25, it's 25 pi cm per second, which equals over 0.0127. So we got this one right here. Let's look at a second example. Okay, so this next example is just a written sentence or paragraph or word problem, whatnot. Just a bit harder, so you gotta understand how it is. Basically, a ladder 10 feet long rests against a vertical wall. The bottom of the ladder slides from the wall at a rate of 1 foot per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet away? Well, this looks pretty just hard to understand, but if you were just to draw the diagram out, you're gonna see that it's pretty easy. So you see that it's a ladder 10 foot long rests against a vertical wall. Let's just say you have a vertical wall like this, and then you have a ladder resting on it, and it's 10 foot long. So let's go 10 feet. Yeah, so you have a ladder resting on it like that. It's just the ground, pretend it's straight. Anyways, and if the bottom of the ladder, it's sliding down, so it's falling down, it's sliding at a rate of 1 foot per second. So let's say, yeah, this part right here, let's just call this X, and let's call this Y. And right here, this is, it's moving at, well, so let's just say the dx over dt, or the ladder here is moving away. It's basically rate change, right, at, this is equal to x prime, this is going to be equal to 1 foot per second. So basically, yeah, the rate change of the x coordinate here is changing at 1 foot per second. That's all that it means here. The bottom of the ladder slides away from the wall. And then now it's saying how fast is the top of the ladder sliding down the wall when the bottom is 6 foot away. So let's say, yeah, so basically it's saying, well, what is this? Yeah, how fast is the top of the ladder sliding down, or what is y prime, or dy over dx? I mean dt. This is in time. Equals what? At, let's say x is equal to 6 foot. Because yeah, when the bottom of the ladder is 6 foot away, or that we call that x as the bottom here. So basically, to get this, first we need to get an equation that relates the two. So and then we know that this is just a triangle. So we just use Pythagorean theorem. And this one we know that y squared plus x squared is just equal to, well, 10 squared, or c squared is 100 equals to 100. So basically here, yeah, we know this one right here, and let's just say let's just solve for y here. So for right now at x equals 6, we're gonna get, well, y squared is equal to, y squared plus, well, 6 squared just equals to 100. So right here, this one's 36, so we get y squared is equal to 100 minus 36. This is just equal to 64. And then y is equal to plus or minus square root of 64. This just equals to plus or minus 8. But then negative 8 doesn't make sense in this application, so it just equals to 8. So then we have y is equal to 8 feet. And so we know that. So now this is all we do is we find the equation that relates the two, take derivative using chain rule, and then just solve for the other rate of change. So because in this case we know that the rate of change is this quantity. So let's just solve it right here. So we get, I'll just write this over here, x squared. We use implicit differentiation. Derivative in this case is going to be 2y, then using chain rule, y prime, plus 2x, x prime. This is equals 0, that's a constant. And now we could just rearrange for y prime and solve for it. So we know that y prime is equal to, well, we just take this to the other side, negative 2x x prime divided by, then we're just solving it all out, 2y. Just rearrange that. The 2's cancel. So we're left with, I mean, this is a positive here. So we're left with negative x times x prime over y. And we know that x is just equal to, x is just equal to 6 feet. So this one is 6. And this one here is 8 feet. We just solved it earlier. And this one here, we're given as 1 foot per second. So we're going to write, well, this is equals to negative 6 feet times 1 foot per second divided by 8 feet. So then the feet's cancel, we're just left with the units feet per second. So we're going to get y prime is equal to, this is negative 6 over 8. Just divide this by 2, we're going to get, this is simplified, 3 over 4. Or this is the rate that the ladder is going downwards at. So at 3 over 4 foot per second, that it's going down. It's going down when x is equal to 6. When this is basically equals to 6. When it changes, you're going to have different numbers, because this is based on x and y. So at different points as it's falling down, the rate changes. You could even try that out. Just put a ladder or whatever and try it. Well, anyways, this is all for today. I'll do some examples later on about related rates, some other useful ones. But this is basically what it is. You just get a rate of change of one quantity, and then you get a formula that has the two variables that you're looking at, and then just basically get the rate of change of the other quantity based on the other one. In this case, we get r prime based on v prime, or volume change. Well, that's all for today. Hopefully you learned, and stay tuned for another math easy solution.